Assalamualaikum. Okay, Assalamualaikum warahmatullahi wabarakatuh, and a very good day. So I just want to continue the discussion on the previous exercise from our last class. Okay, so this is actually the exercise where we have already discussed the solution for question number 1, okay, and question number 2. And we haven't finished yet question number 3 because during the class I said that the solution is not correct. It's not correct. Okay, so but after look at that solution truly, actually the original solution is actually the corrected one. Okay, so the questions is actually find the reactive power supplied by the capacitor after the switch is closed. So when the switch is closed, so what is actually the capacitor is connected to the circuit, so it will actually supply some power, which is the reactive power Q. Okay, so this is the circuit after the switch is closed. You have a capacitor that connected in parallel with with the inductors and also resistors. Okay, so to obtain the Q, so what you need to have is actually the information across the information of the voltage across the capacitor and the current that flow inside the capacitor. So for the voltage, so it is very easy because as we know that the voltage across the capacitor, because the capacitor is right now is in parallel with the source. So directly we can obtain the voltage across the capacitor as equals to the voltage source, which is 120 with an angle of 0 degrees. To obtain the current, okay, so to obtain the current, so it is very simple. It's just by using this formula. So the current is equal to the voltage across the capacitor over the reactance of the capacitor itself. And the reactance of the capacitor after the conversion is actually negative J144.7 or 144.7 with an angle of 90 degrees. Okay, so you use these equations, so you will obtain that the current is 0.8390 degrees, or in rectangular form is J 0.83. Okay, so you have already obtained the voltage and the current. So from that, you can directly calculate what is the reactive power of the capacitors. So 120 multiplied with 0.83 over 2 multiplied with sine negative 90 degrees. Okay, so automatically you will get negative 49.8 var. So that is the solution for question number 3. Okay, now let's look on the last example of this topic, example 4. So an inductive AC load draws a 13.4 amperes of current at a voltage of 208 volt. Okay, so the phase shift between the line voltage and line current is measured with an oscilloscope and determined to be 23 degrees. So calculate the true power and also the reactive power. So this is the line voltage and line. This is actually line voltage, line current, meaning that this is actually from the grid. So we assume that these values is actually RMS values, and this voltage also is in RMS values. So the phase shift between the voltage and current, so this one meaning that theta V minus theta I is 23 degrees, positive 23 degrees, meaning that the voltage is, the current is lagging the voltage. Okay, why the current is lagging the voltage? Because this is inductive load. So even though it didn't give you which one is leading or lagging, so it's actually depending on the type of load. So if the load is inductive load, definitely the current will be lagging. So you will, so theta V minus theta I is positive 23 degrees. So calculate the true power. Okay. Okay, so the true power. So you have already obtained that the voltage RMS is 208, while the current RMS is 13.4, and the difference between voltage and current is 23 degrees. So to get the P, you just use VRMS, IRMS, cos theta V minus theta I. So 208 multiplied with 13.4 with cos of 23 degrees. So based on my calculation, your power is around 2.56 kilowatt. Okay, and what about the reactive power? So the reactive power is Q is equals to V RMS I RMS sine 23 degrees. So this one is equals to, so based on my calculator, so the value of your capacitor, the value of your Q is 1.089 k var. Okay, so I think that solve the example 4. So let's look on example 4b. An electrician suggests to you that these power factors can be corrected by connecting a capacitor in parallel with this load. If the capacitor size is just right, it will exactly offset the reactive power of the inductive load, resulting in zero total reactive power. So calculate the size of the necessary capacitor in farad, and assuming that the line frequency is 50 Hertz. So this is related to the previous example. Okay, so for example, I have my source and I have my load, which is RL, which is my P will give you 2.56 kilowatt, while my inductive will have a reactive power of 0.89 k var. So this is a positive. Okay, so by actually parallel inserting the capacitor parallel, okay, so you will inject a negative Q. Okay, you will inject negative Q inside the circuit. Please bear in mind that the total power inside a circuit must equal to 0, and this is applied to P and also applied to Q. Okay, so right now we considered only Q. So because in this case we want to actually make our capacitor here is equal to 0. So meaning that your QC must equals to your QL. Okay, so 0. So your QC should produce negative 0.89 k var. Okay, because QL is positive, so you need to produce QC is equals to negative 1.089 k var. So right now, what is the value of the capacitor that need to be installed? Okay, that is the question actually. So how to get this one? Okay, so it's actually by having this equation I, okay, is equals to voltage across the capacitor over the XC. Oh, sorry. So actually, to get the QC, we can obtain this by using the formula that we got from the notes, which is V across the capacitor square over the XC. Okay. So right now, the voltage across the capacitor, this is only magnitude only, okay, is already known, which is equals to the voltage source. So 100, sorry, this is not 100. What is the values? 208. Okay, RMS. So this one is RMS, okay. Over your XC, we know that your XC is 1 over 2 pi FC, where your Q is 1.089 k var. Okay, so your capacitor can be calculated by solving this equation. Okay, so this one should be 1.089 kvar over uh, 208 square multiply 2 multiply with pi multiply with the 50 hertz. So you will obtain your capacitor. Okay, I think that's all for the topic for this one. So we have finished actually the syllabus for week number 1. Thank you very much.